Hello and welcome to this tutorial on various ways to stop void loop. And what I mean by stop void loop is have it perform a task once, have some task written inside the void loop brackets, perform that task once, and then in a sense get out of void loop so that it doesn't endlessly repeat that task over and over and over again. Anybody who's watching this video has probably experienced something like this. Say, I want this sentence to print once. So I've put the serial print line command inside the void loop. I've given it a delay. I've only entered one line of code. I want it to do this one time. So I've entered it once. Well, when I upload this code, what happens? Well, let's open the serial monitor. Oh, it printed one. Oops. Oh, no. I wanted it to print once. What is it doing? It's printing it over and over and over again. And that's exactly what I didn't want to happen. So, how do we stop that? How can we control if I want something to print once, or I want a countdown to go through from 10 down 9, 8, 7 all the way to 0, and I want that to happen one time in the program? Well, the first option is we can just take whatever commands we want executed one time and just place them inside void setup and leave void loop completely empty. And there's no problem leaving it empty, just empty. And then we can upload this code and check the serial monitor, see what happens. I want this sentence to print once, and it did. So all that we've done is basically place the code that we want to execute one time inside the very function that's made to execute code just one time at startup, namely the void setup. But what happens after it's performed this task in void setup? Well, the Arduino keeps going. It goes to void loop, and since void loop is empty, it just infinite. It's in an infinite loop of doing nothing. That's what's happening right here. So you've basically had the Arduino perform some task and then kicked it off into an endless loop, which is perfectly fine. There's nothing wrong with that. Microcontrollers don't mind being in an infinite loop. There is no operating system, so there is nothing to return back to. So it has to do something, so it'll spin itself in an endless loop. But what if we wanted to be able to actually control void loop itself? Like, say, if I want to have this sentence printed once, let's cut it and then paste it inside void loop again. Say I want some task to be performed one time. This sentence is just a stand-in for whatever group, single task or multiple tasks one would like performed one time. Close this, tighten that up. And what if I want it to be accomplished inside void loop? Well, think about what happened when we placed it up in void setup. We placed the sentence inside void setup. It printed once. Then it moves to void loop and it spins in an infinite loop. Well, couldn't we just construct an infinite loop at the bottom of void loop and then have the sentence print once and then pitch it off into that infinite loop? Absolutely. You can do it using this sort of idiom in the C language known as an empty for loop, that it has no initiation point, no test, and no increment or decrement, and then its brackets are empty. Just to note that, you could say empty using the multi-line comment structure. And then, well, does this work? Well, we can upload it and see. Check the serial monitor. Yep, I wanted it to print once, and it did. But is this the only way to keep the Arduino in an infinite loop? No way. There's at least two others. You can go while and then say 1 and then have it empty. You can use what's known as an empty while loop. And what happens with this while control structure is as long as its condition is true, it'll do whatever's inside its brackets endlessly. And this is the trouble with while loops most of the time, is you've got to remember to update some counter variable in the back end and the bottom end of a while loop, or either you'll be pitched off into an infinite loop, especially when you're doing programming in the C language or C++ or Python, etc., etc. You got to be sensitive when you use while loops, because they can be kind of dangerous where you have to hard stop the program if you pitch it into an infinite loop. Well, in this case, we can use it in the microcontroller scenario to our advantage and actually have the Arduino do some task. I mean, and this can be multiple tasks. I mean, we could have serial, front line, I don't know, cats are great, whether one agrees with that or not, and etc., etc. We could basically have blah. However much blah we want to occur before that while 1 will only occur one time. So just to test that, I can upload. And check monitor. Yeah, I want this in a sprint once. Cats are great. Now at this point, what's happening with the Arduino? It's spinning itself in an endless loop. That's exactly what it's doing, which is perfectly fine, because as far as all outward behavior goes, what we really care about, it did what we wanted it to do, and then it stopped. It stopped, in scare quotes. It didn't stop doing everything. It's still spinning right here, but it stopped at the point we wanted it to. So we have ultimately total control over when void loop stops. That empty for loop we just discussed, and this while 1 will do it. While true will also do the exact same thing. We can change this around just to verify. Puppies are great. Upload the code. And then verify through the serial monitor. Well, let's send a sprint once. Puppies are great. So this sort of casting void loop into an infinite loop at the very bottom, like there's the close bracket, the void loop, will give us the ability to do whatever task we want it to run through one time, and then it throws it into an infinite loop. That's 3 different styles of infinite loops, just to show them one more time. Have an empty for, we can have while 1 with empty braces, or you can have while true. Any of those 3 will work. And there's probably tons more. The C language is known for being able to do really neat things, these sort of idioms of the C language. So that's all one has to do to be able to stop the void loop at the bottom and cast the Arduino into an infinite loop. But what if we want to be able to have, in a sense, a little more technical control over that? What if we want to vary whether it goes into an empty or an infinite loop or not, based on something that occurs prior to that? Well, you can definitely do that too. And this is the option that I tend to prefer. I tend to like to write games with where the Arduino is, where there's a single player and the Arduino is requesting moves in the game. The player enters those moves. The person plays the game. They either win or lose, and then it asks, do you want to replay the game? And based on their answer to that question, it either restarts void loop or it halts it. Or, well, it puts it in another form of infinite loop at least. So how would we do something like that? Well, we can start with a global variable of the Boolean type. Let's use it so that we're thinking more in terms of a game. Let's say the replay variable. And let's set this variable initially to true. And note, with a global variable, this is going to scope over everything that comes below. So inside the void loop, what we can do is test. We can use an if control structure. We can say if replay double equivalence is true, then do something like in here, play the game. And then after the person finishes playing the game, we can do a request like, do you want to play again? Have a sentence to that effect sent to the serial monitor, and then have the other sorts of serial available functions catching the player's answer, and then depending on whether whether he or she answers yes or no, we can toggle or keep the replay value the same. Let's say we toggle it to false. So replay equals false. And then close down void loop with that bracket. And so just so we can see this, let's say serial enjoy the game. This should just print once. Let's see if it does. Upload it. Enjoy the game. It printed just once. Why? Well, because what happened is initially we have the replay value set to true. It goes through setup, hits void loop, says, what is the value of replay? Well, if it happens to be true, then print that sentence. And then after it exits the if, the replay, which is a global variable, keep in mind, the value has been toggled to false. So as soon as we toggle it here to false, it's changed to false up here on this bottom pass. And so when it loops back around, when void loop comes back around, replay is no longer equal to true, so it stops. But it doesn't really, Arduino doesn't stop doing anything. No, it keeps checking. Basically polling, is replay true? Is it true? Is it true? Is it true? And given that it's been toggled to false, no, it's not true anymore, so it'll never kick back into the loop. It'll never repeat. But you can control that. I mean, and I'll have more video tutorials about the code involved in actually toggling this value based on user or player input. But that's the simple structure. This is my preferred structure. This is the preferred way. For me at least, prefer this method or technique. Just set up a global variable, a Boolean type, have it set to true or false depending on how you want it to play out in the end. Have void loop begin and immediately drop into a if test. And then have something occur inside that if test, whatever I want to happen one time through, and then at the bottom toggle the value to false. And that'll basically, it forces void loop to act like setup, except the beauty of this structure is that you could add more control code in here and actually have a person control whether this value toggles false or true. And if in case you want it to run again, you could have it toggle true, and then when it comes around, it'll play again. Just to see that, all that would have to happen is just set it to true. This sentence will print. Let's put a delay in here so we're not wiped out with it on the serial monitor. So every half second, enjoy the game should play on the serial monitor now. Open the serial monitor, enjoy the game every half second. See, so all you need is code to control the value of replay, which that's pretty simple. That's just more ifs and more testing. Now, there is another option. There's actually many more options, but say someone wants to create a kind of fancy stop the void loop function. That's totally possible too. Just to be consistent with something like that, let's rename our global variable. Say we want to have a Boolean, a stop it variable, and set it to false. So this is saying, do we want to stop it? No. And all we would need is to create just a function that returns updates to the stop it variable. So we could have, given that we want it to return a Boolean type value, so stop main loop. This will be, we can refer to this as the fancy stop main loop function. This isn't really the method that I would pick, but it does work. So what does one do? Well, you're basically going to do that same sort of if structure inside this. So let's clean out void loop, just so this isn't too confusing. So we have an empty void loop, and we're just building a special purpose stop main loop function. What we'd want it to do is every time it's called, we'd want to test that stop it variable. If stop it equals false, namely we don't want it to stop, the main loop to stop, then do something. So let's say serial print line, just so we know we're inside the stop main loop function. And then we can, at the bottom of that condition, do something very similar, just like we did before. We can say stop it equals true. So after we do whatever happens inside the if, we toggle the stop it value, and then just to cover all bases, because sometimes modifications inside a function, you'll create variables that you think they're global but they're really not, and to avoid all that, you can just return whatever the updated value of stop it is. So return stop it. And this will effectively shove the updated value outside of the bottom bracket to the stop it main loop function. And then all we'd have to do is inside void loop have the same stop it variable. Stop it is going to be equal to, well, whatever the value, the updated value, was ejected by the stop main loop function. So whatever this return value happens to be, so in this case stop it's going to equal true, so it's going to return that value, namely true. So this is going to, in a sense, be replaced with true, so stop it's going to equal true. And then it'll hit the bottom of void loop, but this is going to force that value to toggle at the global level. And then when all of this rolls back around, stop it won't be equal to false anymore, and this sentence won't print again. So we can test it just to make sure. This is the more complicated way to do it. But for a person coming from using other sorts of programming languages that likes building little functions, see, inside the stop main loop function, and it only executed one time. And at this point, what is the Arduino doing? Well, it's continuously rolling around checking that condition. And it just so happens that that condition is true, so it never executes this line of code again. And that's just a sort of fancy stop main loop function. That's one way a person could go about stopping the main loop, using a specially created function to do it. Like I said earlier, this isn't my preferred method, but it does work. It tends to use a little more bytes too, because every function call takes a little more bytes than just using a overarching if structure inside a void loop itself and doing away with this. But memory is always a concern in the Arduino context. RAM is, at least. So, but this is an option. Now, one could also, as a final sort of humorous option, let's take this out. Take this out of the main loop and take this away. And say that you want the Arduino to do something just one time and then say stop everything, like cut its power off. Well, all you would need to do is have code so put whatever code you want performed once there, and then under here have, say, a servo flip power to ARD switch, and have a switch built into the power cable for the Arduino, between the Arduino and the battery. And then your very last command in void loop is have that servo pull that switch open. That's one way you could do that, but then you kind of are in a bind. You're going to have to manually flip the switch back. But that's one way to do it. Another way would be have some sort of latching relay set up. I've done this myself, where you have, say, a security system that you've built for your home or your workshop or whatever, just playing around with the Arduino, and you have it consistently checking a whole bunch of sensors, a whole bunch of proximity sensors, etc., and then once a person pushes a button on the outside or their fingerprints recognized or whatever, you have the very final command on void loop. It's like it's continuously checking those sensors, and it ignores this value until some other external event occurs, at which time it flips a latching relay that cuts the power off to the Arduino, and in turn the whole security system is disabled. And that's also an option. Just something to think about. There's an interesting, kind of really humorous discussion about all these various ways of, even, really humorous ones of, you could have a servo and drop a hammer on top of the Arduino or whatever. And that's the beauty of the Arduino, is you can control the external world, and all you have to do is control the power to the Arduino as its very last command inside void loop. That's always an option too. But as soon as you power it back up, it's going to start that loop all over again until whatever value's toggled to trigger these other events. But I hope the discussion of these various ways of stopping that pesky, endlessly repeating main loop, this discussion has been helpful. And if you've liked this video, definitely click like on it and subscribe to my channel.